Hi everyone, I welcome you all to Applied Thermodynamics video class. My name is Revanna K. I am working as an assistant professor in Department of Mechanical Engineering, Government Engineering College, Chamarajanagar. The subject Applied Thermodynamics is assigned to 4th semester Mechanical Engineering with a subject code 18ME42 as per VTU curriculum. Applied Thermodynamics is a continuation and an advanced study of basic thermodynamics, what we studied in the earlier semester. By basic thermodynamics, we came to know what exactly a thermodynamics deals and how it is coined as a subject in the field of engineering and science. Apart from that, we were also discussed about the various terminology used in the subject and their definitions in thermodynamic context. In addition to that, we were also studied the various laws of thermodynamics proposed by common experience and observation. That is, first law, second law, and third law of thermodynamics in addition to zeroth law of thermodynamics. The first law is simply an expression of law of conservation of energy principle. It is asserts that energy is the property of thermodynamic system. The second law asserts that energy has both quality as well as quantity, and actual process always occurs in the direction of decreasing quantity of energy. In addition to that, third law says that the entropy remains zero at an absolute 0 degree temperature. In addition to that, another important law proposed, that is zeroth law of thermodynamics, it says that it gives information about the thermal equilibrium, so that this concept helps us to find out temperature measuring devices called a thermometer. By making use of all this thermal knowledge, we can going to analyze the various thermal devices using in the field of engineering and science in order to improve their efficiency and performance by utilizing the knowledge of thermodynamics. The subject applied thermodynamics is divided into 5 separate modules in the given course with a different contents. The module number 1 has 2 topics, that is ASS1 cycle and an IC engine. The subject applied thermodynamics having several objectives. Let us discuss the various objectives of the course applied thermodynamics. Number 1, to understand application of the first and second law of thermodynamics in order, by applying various gas processes and cycles, and to understand the fundamentals of an IC engine, construction and working principle of an engine, and also compare the actual fuel and air standard cycle performances. Similarly, to study the combustion method in spark ignition and compression ignition engine and their controlling factor in order to exploit the maximum power. To know the concept of testing in IC engine, I mean internal combustion engine, and method used to estimate to find the other variable in order to find out the efficiency of the given cycle, that is indicated power, brake power, and frictional power. The objectives we are discussed so far is limited to the module number 1. The remaining objective of the course learning is discussed in the later class. The main application of thermodynamics is the analysis of thermodynamic power cycle or thermal power cycles. The thermal power cycle or a power cycle is continuously absorb and heat energy into converted into a mechanical work. A thermodynamic analysis of heat engine gives a valuable information regarding to a new cycle design, and also it helps us to improve or refining the existing cycle. The heat power engine cycles are classified based on the purpose of the cycle, either to produce power or to produce refrigeration. Based on these power, we classified as number one, heat engine or a power cycle. Similarly, refrigeration or heat pump cycle that we were discussed in detail in the earlier semester in terms of efficiency and also the coefficient of performance in order to satisfy demand of human being. Any thermodynamic cycle you consider, it is essentially a closed cycle. It means the working substance undergo a series of processes and always return back to its original state after performing their task. But there is a few cycle which working under a open cycle. It means that the working substance we use in the cycle, it is continuously absorbed in one side from the atmosphere, and another end it is continuously rejecting after uh, utilizing in a given cycle with the various process. The following illustration or example is considered for open cycle. That is number one, petrol or a gasoline and diesel engine. In this engine, the engine cycle, the air and fuel will be drawn from the fuel tank. After combustion, that will be exhausted into an atmosphere. Similarly, when you came to steam locomotive or steam engine, in which what is the working substance that is drawn from the tank into a boiler, after that will be converted into a steam in the various state. Ultimately, it will be exhausted into the atmosphere after performing some task. This all gives about how an open cycle going to perform its task without recirculating the working substance. Essentially, such a device do not form a cycle. However, that can be analyzed by adding some imaginary process to make it to complete the working substance a cycle. Here we can note that the cycle closed or open used here do not mean a closed system cycle and open system cycle. In fact, the processes both in closed and open cycle could be either be a closed or an open cycle process. Similarly, based on the nature of working fluid in a power plant, we can classify it as vapor power cycle and gas power cycle. In a vapor power cycle, okay, the working fluid is undergo change of state by changing its phase. But when it came to a gas power cycle, the working substance used in the cycle, it never going to change its phase, but it retains the same phase throughout the cycle. The example for a gas power cycle is air standard cycle. Any thermodynamic power cycle you consider, the main interest to the cycle analysis is